Hello, Chemistry 2341. Here we are. We're going to talk about another homework set. And so we're going to do Chapter 5 homework today. So let's get into that. That's chirality. So we know we need a lot of practice for this. And I'm going to show you a couple different ways to attack these problems. When we have a problem like this, 33A, we want to draw out the compound and see if there are any chiral carbons. So we have dichlorobutane. So let's draw our butane. Right here, 1, 2, 3, 4, and then dichloro, one is a chlorine here, and the other would be a chlorine there. Okay, so this chlorine right here, this carbon is not chiral. The one carbon is not chiral because it has two hydrogens on it. But if we look over here, we can put a hydrogen here. And so we have 4 different things bonded to the number 3 carbon, and therefore the number 3 carbon is chiral. Okay, so let's look at number 2. I'm sorry, B here, and that's 1,2-dibromopropane. 1,2-dibromopropane. Bromo, bromo. So if we look at the number 1 carbon here, we have 2 hydrogens on it, so that can't be chiral. We look at the number 2 carbon, we have 4 different things on it, and therefore, yes, this number 2 carbon is chiral. All right, let's do number C, which is 1,5-dichloropentane. 1, 2, 3, 4, 5. So now we have 5 carbons. We'll put the chlorine on one end and a chlorine on the other end because it's 1, 5. And if we add our hydrogens here, just to double check, it looks like we have 0 chiral carbons on the 1,5-dichloropentane. Okay, let's look at D, 3-ethylpentane. So 1, 2, 3, 4, 5. So we have 5 carbons, and we're going to put an ethyl group on the pentane here. So let's see, let's add our hydrogen to make sure we're looking for stuff. We have 3 ethyl groups attached to the same carbon. Therefore, we don't have 4 different groups. Therefore, it is not chiral. All right, so now we have E, which is bromobicyclobutane. So we have 1, 1, 0. So we're going to draw our bridgeheads. We're going to draw our 1 carbon bridge, our 2 carbon bridge, and our 0 carbon bridge right here. It's 2 bromo, so we have to start at this for 1, and so we're going to have a bromo here. Let's see, I think we're probably going to have a situation where we don't have a chiral carbon because if we keep going around the ring this way and we keep going around the ring this way, they look the same. So I don't think it is chiral. All right, so remember what we're looking for is the 4 different things bonded to the same carbon when we're trying to assign chirality to a carbon center. Okay, so let's move on and start assigning R and S right here. So we're going to start designating these R and S. I'm going to use 2 methods in the homework because the hand method I'll use, but I'll also use an orientation method where we kind of flip things. And so, for example, if we look at this first one right here, if we draw our hydrogen is already behind us. Okay, so our hydrogen is probably the lowest priority, and so it's probably behind us. So we can just assign priority and do R and S from the front here. So chlorine is going to be number 1. The carbon with a carbon bonded to it is going to be number 2. This is going to be number 3. And of course, our hydrogen is going to be number 4. So that's 1, 2, 3, and that's a clockwise motion. So this first center here is going to be R. Okay, so now let's take that away and let's do the next center here. So let's do this one. In this center right here with the fluorine on it, we're going to have to use our hand. Okay, and since the hydrogen's facing toward us, we're going to put our hand directly on the page there. And my index finger is up. So I'm going to put the fluorine there, and that's going to be number 1. The carbon with the bromine on it is on the right, and it's going to be number 2. And then the other carbon is going to be number 3. So 1, 2, 3, 1, 2, 3. Let's look at it perspective-wise. And that is also going counterclockwise. Oh, that is going counterclockwise. So that makes this an S. Okay, so we have to use our finger or some other method on that. The other way to do this, and you have to use one method or the other, but the other way to do this is to say, this is our 1 priority, this is our 2 priority, and this is our 3 priority. And that's going clockwise, but we have to flip it around to make it the correct perspective. So the hydrogen's going back, and therefore it's going to be counterclockwise, giving us S. So that's one other way to approach these when they're written like this. So that being said, let's go ahead and assign the rest of these. We have a really good job because these right here, these hydrogens are in the back. So all we have to do is assign a priority, 1, 2, and 3. So that's going counterclockwise. So this is also S. All right, now let's talk about assigning the priorities here, okay? So we have a chlorine and a fluorine on here that we're trying to look at. So the bromine is attached directly to the carbon, and then this carbon and this carbon are the same. So we have to use rule 2 and go out. The chlorine is higher than the fluorine, and so that gives us this, our number 2 designation. This is our number 3 designation, and our hydrogen is number 4. Okay, so let's go off and do our last one now. And let's see, we can look at it from the front because the hydrogen is going to the back. So we're hydrogen going back. And this is going to be our 1 priority, our 2 priority, and our 3 priority. So that's going counterclockwise. So this is also S. All right, so that's one great way to do this. Now let's move on to the second one here, the next one here. And I think we're going to have to use our hand on this. So we're going to have to really go a long way around that ring to find a difference. This carbon is different than this carbon because of the chlorine here. So this is higher priority than this, okay? So we'll see which numbers they are. Okay, so chlorine is higher in number than our nitrogen, so that's going to be 1. Nitrogen's higher than our carbon, so this is going to be 2. This one has the chlorine on it, so it'll be 3, which makes this one 4. Okay, so now perspective-wise, we can use our hand model there, and the chlorine is coming out at us. So the chlorine coming out at us is going to be my thumb on my right hand. Then the nitrogen is going to be my index finger, and the other benzene ring is going to be on my middle finger. So that's 1, 2, 3, 1, 2, 3. That seems to be counterclockwise to me, so I think that's an S. Okay. See how we had to go all the way around the ring to assign that priority though? Okay, and now we have a good one here because both of these are facing backwards, so we should be able to just assign them directly by having our hydrogen in the back here. Again, this bromine is going to be priority. This carbon with the fluorine on it will be 2nd, and then this one will be 3rd. So let's assign those as 1, 2, 3, and we're going counterclockwise, and our hydrogen is back, so we're going to keep that as our S designation. Okay, so let's do that same thing for our fluorine here. The fluorine is going to be number 1. The carbon with the bromine on it's number 2, and this is going to be number 3. So that is going to go counterclockwise. Okay, all S. That's weird. Let me double check this last one here. 1, 2, 3. They're all counterclockwise. That's interesting. Anyway, so it's also S. Well, I wonder if they knew they were doing this. All right, so let's go on here. Okay, so we have 2 chiral carbons, the one here and the one here. This one has a hydrogen on it back here, so we're going to do that one first. So the sulfur is going to be number 1. The carbon with the sulfur on is number 2, and the carbon with just the hydrogens is going to be number 3, which is counterclockwise. No, that's clockwise. Oh, yeah, so this is R. That's kind of, yeah, okay. Huh, just convincing myself that that's true. So that first one's R. So we're going to label that the blue chiral carbon. And now let's do the red chiral carbon. So let's see, we have, this is obviously going to be number 1. This carbon with a sulfur on it's number 2. This carbon with a number carbon on it's number 3, and this carbon's number 4. Now notice that's facing backwards too. So we'll be able to just go 1, 2, 3. And so this is S. Okay. Okay. Do we see how to do that just looking at it forward? If we were going to use our hand on this, I would hold my hand such that my fingers were pointing toward me. I'd put the sulfur on my thumb, the carbon with the other sulfur on my index finger, and the carbon with just the 2 hydrogens on it on the last finger, and that would still give us a counterclockwise direction, which would give us S. Okay, so that's number 35. All right, let's get some more practice here and look at these Newman projections, figure out which one is RR, SS, and RS, and which one is a meso compound. Okay, so let's just look at our Newman projections for a second here. If we rotate this methyl group around to be eclipsed with this methyl group, our chlorine is going to be rotated around, eclipsed with the chlorine, and our hydrogen is going to be rotated around, eclipsed with the hydrogen. What that's going to give us is that's going to give us all of the different molecules line up, and therefore this is going to be our meso compound. Okay, it still has 2 stereocarbons we're going to identify, but I wanted to show you by doing that. And notice that right here, we have a mirror plane between these two. So that means these are enantiomers. Okay, so we need to, we can assign those just by looking at them, showing that this rotation would give us eclipsed positions, which would give us a meso compound. And this one will not. We cannot do that. We're always going to have a chlorine and a hydrogen interaction by rotating those lines. But that mirror image there tells us we have enantiomers.